Integration of standard functions, part 1. Integrating x to the power of n cannot be equal to -1, so we can't integrate x to the power of -1 or 1 over x or 3 over x and so on. A more useful version of this is a linear function, so ax plus b is a linear function raised to a power, and we've got the same on the other side, so we're increasing the power by 1 and then we divide by that new power. We're also dividing by the coefficient of x, so we increase the power by 1, so we've got x to the power of 5 over 3. We're going to divide by 5 over 3, which is the same as multiplying by 3 over 5, plus a constant of integration. So in this example we have to rewrite the x plus 3 squared into its proper form first before we integrate. So x plus 3 in brackets to the power of -2, you're changing the sign here from +2 to -2, and then we've got x plus 3. We increase the power by 1, we divide by the new power, we divide by the coefficient of x. We were multiplying by 6, we're still going to multiply by 6, plus a constant of integration, and then we simplify to this, which we can write as this if we want to, but it's not necessary to do this. This was the final answer. Okay, part C, so we have 5 minus 4x, a linear function. We increase the power by 1. We divide by the new power. We divide by the coefficient of x, which is -4, plus c, and then simplify. It might be more useful, depending on the problem, to rewrite your final answer like this, or like this, and you'll notice the factor here is not the same, but if we expand 4x minus 5 squared or 5 minus 4x squared, they give the exact same result, so these are the same. So how do you convert one to the other? Well, let's start with this, and I've factorized out -1 from these two terms. So just to check, the -1 times the 5 gives you the -5. The -1 times -4x gives 4x. And everything was in brackets, as square brackets, and was squared. So these are still the same. The power of 2 will go here, outside the bracket there, and it will go on the -1 if I was to put that in brackets, like this. And -1 squared is 1, so it's just 1 times the 5 minus 4x squared, so we get this. That's how you convert from here to here. Integrating exponential functions, again, e to the power of, and the power is a linear function of x. So you've got the same thing on this side, e to the power of ax plus b, but we're dividing by the coefficient of x. Okay, so integrating, it will give e to the power of 1 minus 3x. Again, I need to divide by the coefficient of x, which is -3, plus c. In this example, the base is the same, so we need to simplify the indices first. So e to the power of t minus 1 minus 3t. Because we're dividing, we subtract the indices. So we have this, simplifying, and now we do the integration. So e to the power of 4t minus 1 again, but we divide by the coefficient of t, so we're dividing by 4. In this example, I've got another exponential that needs integrating, so e to the power of, and this is a linear function, 3 minus 4k, and k is just a constant, so a linear function of t. Then I need to divide by the coefficient of t. I'm integrating with respect to t. The coefficient of t is -4k. I was multiplying by 0.28, so let's put that back in, plus c.